Good morning, everyone. Thank you for attending today's webinar. We'll begin in just a moment. First, I'd like to conduct a bit of housekeeping. Using the hand icon in the GoToWebinar control panel, can you please let me know if you can hear me? And let's see here. Do I see any hands? Yes, thank you very much. See a bunch of hands. Next, during the presentation, you will be on mute, but should you have any questions about the discussion, go ahead and enter them in the questions field in the GoToWebinar control panel. At the end of the presentation, our speaker will take as many questions as there is time left. And I will also be sending out a link to both the recording and the slides after the presentation. So if you have an emergency that takes you away from the presentation, don't worry, I'll make sure you get the slides and the recording. We understand how that goes. I'd like to thank you for attending today's webinar, Powering Financial Fraud Detection with In-Memory Computing. It's being presented by industry consultant Eric Cartman. And with that, I'll turn the floor over to Eric. Go ahead, Eric.
Thanks, Alyssa. Good morning, good afternoon, everybody, depending on which region you're in. I'm in New York, so it's nice and sunny afternoon here, and good afternoon to everybody. Today, we are going to continue our series of webinars that are actually centered around different topics that are very current and need to be resolved quickly within financial services industry, something that we are all working on within the industry. Some of our clients are struggling with, some of our colleagues are asking us to address, and one of the topics we will be presenting today centers around financial fraud prevention. This is a hot topic. I hear a lot about it. It's an issue that we all deal with in finance as well as in our daily lives. And I think especially if you are working for financial firms, everybody now is worried about losing reputation or reducing confidence in industry or in financial institutions that we represent. And there are different ways of combating this problem. And I'm going to talk a little bit about how different firms address this, and then we'll talk about GridGain and where I believe the In-Memory Data Fabric product from GridGain is really a perfect fit of addressing those issues within financial institutions. Let me go to the next slide. So what is financial fraud? I mean, and this is what we're talking about here. I mean, everybody has different definition. Some different categories exist. To me, financial fraud is a way of intentionally use, different illegal methods or practices for the purpose of obtaining financial gain. And these are different items here that I list that might be areas where financial fraud needs to be checked and where we've seen recently different instances where financial fraud would show up. Obviously, checks. This is the oldest fraudulent activity, where checks are written by institutions that do not have the right authority, or maybe signed by non-authorized officers. Credit cards. Obviously, this is something again we hear about a lot of times. Identity theft and credit cards in many cases come hand in hand. Mortgages and corporate fraud, different financial statements are being changed and illegally manipulated. There are securities fraud, obviously, is also a big thing, where there are all kinds of different abuse, manipulation, and other illegal techniques that are being used while trading different securities. Payments is a big thing, where again sometimes the payments are rerouted to places where they shouldn't go. Sometimes there are again, fraudulent payments requests that are coming into banks that need to be stopped. Identity theft, as I mentioned earlier, is a big topic where a lot of Americans had lost their financial information, and people are making money on wrong identities, illegal identities. Forgery is another area of concern. Computer fraud is a big area where, obviously as we are moving more into computer-based banking and computer-based financial transactions, that's an area where also fraud is a big concern. Tax evasion, obviously is also quite big, as we're losing the governments and people are losing money because of that. And it's just a number I found a couple of weeks ago that says Americans lose an estimated $50 billion a year to fraud. That's a huge amount that obviously needs to be dealt with. And how we have traditionally dealt with this. Traditionally, there were traditional approaches usually relied on all kinds of manual techniques, where basically people were auditing transactions and they were trying to do manual checks, manual analysis of data of who is calling, who is giving them the right password, what information they provide. But there was really not much of way of really automating this process. I think as technology progressed, we are able to collect much more information than before, and we have the different techniques that basically help us to collect data, to prepare data, to classify data, to analyze data, and then to create some kind of action. That's basically what we are mainly dealing with here, with different steps of prevention. So we first need, in order for us to stop the fraud, we need to collect it. We need to make sure the data is adequately classified. We need to know that basically it is an event, without much of without a need of further action. We can stop that from happening. This is an example of a duck, where that walks, that swims, that quacks, but sometimes it's a duck, sometimes it's not a duck. So you have to do more than just your basic data analysis. Now, when we talk about financial fraud detection at different banks, this is maybe something familiar to you, as the different banks are trying different approaches to fraud detection. What do? Well, they do data pre-processing techniques for detection, for validation, for error correction, for filling up of missing or incorrect data. That's usually the first step of preparing and processing data. Then they go into calculation of various statistical parameters, such as averages, quantities, performance metrics, probability distribution, correlation analysis, and many more other types of statistics and probability analysis. For example, the averages may include average length of a call, or average number of calls per month, or average delays in bill payments, or the place from which the call originated, and so on and so forth. Then there are also models and probability distributions of various business activities, either in terms of various parameters or probability distributions. Then we need to compute and maintain user profiles. Then there are all kinds of advanced analysis that may be performed related to time series analysis of time-dependent data. There's also clustering and classification in order to find patterns and associations among amongst different groups of data. Then there are also matching algorithms to detect anomalies in the behavior of transactions, or compare users to any of the previously known models, profiles, historical patterns, and so on. We also need additional techniques to eliminate, false positives, false alarms, capture upcoming risks, doing some kind of prediction in terms of the future of current transactions or users. And for that, obviously, artificial intelligence and machine learning are some of the examples that are being used today for successful fraud detection and stopping fraud, basically, forensic analysis of some sort. Fraud management is also a knowledge-intense activity. Artificial intelligence techniques are used in many cases for fraud management. Data mining and expert systems and pattern recognition, machine learning, neural networks, many other types of approaches that are known today from the scientific world, as well as from trading, from quantitative science. And we've, using that together with technology that's not so necessarily using for fraud detection, but for data analysis, for fast data analysis, for transactionally intense data analysis is mainly what's being used by financial firms. They do use big data because, as we said in the beginning, we need to prepare the data and we need to have the data available for analysis. So big data is a good concept here where you can organize data into multiple pools and connect them in real time for real-time detection and association. Also Hadoop with MapReduce. Again, in order for big data to work efficiently here, because let's not forget, we are talking about stopping fraudulent transactions while they're happening. And an average speed of executing a transaction may be milliseconds, right? And within those single-digit milliseconds, you have to analyze this transaction, you have to validate this transaction, you have to check all available data pools and make sure that you are not affecting the performance of processing this transaction. And that's what Hadoop with MapReduce is supposed to do. It's additional data analytical model that helps you to organize hierarchical data in order for you to quickly come up with a conclusion of whether this transaction should proceed or should be stopped. Complex event processing with data streaming. This is also another area that's being used in many financial institutions today, where you have multiple streams of data coming in, and based on any one tick or any one element of data coming at any one point, a whole decision within this neural network or within that artificial intelligence paradigm needs to happen to, again, decide whether this element that just came in is supposed to change behavior of the entire system or behavior of how the detection will occur, or any of the information that may be coming in while the transaction is still being processed. Sorry, somehow have doubles here. But then near real-time systems, again, this is just to mention that you have to have very fast, very efficient system available to you in order to stop those transactions while they're happening. Because it's usually much more expensive to solve this fraud issues after they occurred. It's reputational risk, it's people risk, it's you might have been exposed to many transactions of a similar type. It's just a messy situation. You want to stop, you want to be proactive, you want to stop your transactions while they're happening. Near real-time systems is what's required today. Now, data partitioning and parallel processing clusters obviously also quite important because, again, performance is an issue, and you have to send this data in real time, and you have to have multiple processors operating on this data. Because think of it this way, you have a lot of transactions coming in at the same time, and you cannot line them up one by one to be checked for fraud. You have to have the distribution available on your clusters to process those transactions regardless where they come into. You need consistency with your data, and that also is guaranteed or desired with data partitioning and parallel processing clusters, basically cluster technology. Scalable data architecture. Again, we are operating in the world of constantly growing data, right? What we have today is not the same as we had yesterday. So there are 20, 30% data growth year to year at any of the large financial institutions that I have been dealing with lately. And that's, again, a concern that you have to address. You cannot run out of space. You have to constantly being able to add more storage while not losing any performance, because this is the paradigm here. Usually when you have when you're adding more storage to be more scalable, you are losing some performance numbers here, and some performance efficiency. Again, scalable data architecture without losing that performance perfection is really what's important here. And in-memory computing, again, we think that because fraud is so much scientifically, analytically intense, that you do utilize some of those very advanced, performance-hungry models. You need to do them the fastest possible way, and the fastest possible way today is in-memory computing, where you can process the data, when you can analyze the data, when you can approve the data, when you can model the data all in super real time in memory is obviously much better than any of the other storage-based computing that banks normally utilize today. What I'd like to move next to is really our evolution of in-memory grid computing, and I will talk a little bit about grid computing in general, and then what GridGain is doing in terms of in-memory grid computing, and then I will also explain how that can be applicable to different fraud detection practices that we've discussed just now. So I think, as I kind of alluded to just now, that there is a tendency disk to 100% in-memory computing. That's that's clear. That's where I think the market is moving to, especially for those applications that require a lot of processing power, that require heavy analytics, that present many transactions that that are coming in and need to be processed in real time at the same time, hundreds, thousands, millions of transactions per second. Then the clustered memories, again, as I mentioned to you before, that we believe that, yes, moving from disk to memory is a key, but not enough to guarantee the enterprise level memory processing, memory operational. You need to have multiple machines performing at the same time. You need to have enough high availability, disaster recovery, concurrency within your systems, and clusters and parallel distribution are the key components to guarantee that. As a result, what we've seen with some of our clients that implemented this type of in-memory grid computing for fraud prevention and for detecting different anomalies with transactions that are coming through, is that they can process those transactions about 100 times faster with the 10 times return on investment improvement. Why it's faster? It's clear because we are moving from disk to memory, and obviously that brings in those types of results. Obviously, hundreds of times faster performance, but also ROI because in memory became significantly cheaper, and today it may be slightly more expensive than disk, but for the performance that you get, it is significantly faster and brings you significant performance improvement. So when you do your return on investment analysis, you also have significant improvements there. And what we like to call it making big data fast, because any applications that rely on big data, and as we said, fraud detection, fraud prevention categories, one of those examples that utilize big data and need to make big data fast. So when we need to make big data fast, that's what we propose to our clients to use in-memory grid computing. Our clients obviously use us for multiple models for different use cases, but obviously fraud prevention is a big thing here because of when you see big data analytics, when you see financial analytics, when you see compliance and monitoring being listed here, in many cases they rely heavily on fraud detection, anti-money laundering, know your customer, market manipulation, view of your customer in real time, real-time analysis of positions, complex event processing that I mentioned earlier, pricing again. So if you utilize us for any of the financial needs, financial uses where a lot of transactions are being processed at the same time, that's normally where we play the best in the best possible way because of again, ultra low latency and real-time processing of data and analytics around this data. So I've listed some of the clients here. As you can see, some of the largest banks of the world, Barclays, Citi, Sberbank, and others are utilizing already GridGain. And in many cases, they do that for data processing and analytics, including fraud, AML, KYC analytics on the transactional level, right? That's where I believe our difference can be clear, that you don't take the data to another system that will provide analysis of the data and then approve or disapprove the transaction. That may be too late. So that either will result in performance degradation or will result in post-transaction processing type of situation where the client will not be able to complete transaction until all of those steps are being performed. With us, because we do most of the compute on the data level, we are actually able to provide that super fast transaction processing without much of a slowdown or noticeable slowdown to the clients, and basically approve those transactions or check against the models of those transactions and allow them to go through. Obviously, that results in a safer environment for our clients using transactional processing. I'll give you one use case where I think we've mastered this. So the case is of Sberbank. This is the largest bank in Russia and Eastern Europe, and the third largest in Europe. And obviously, they've gone to a point that they basically could not validate transactions while they were happening. The reason for that was that from traditional office approach, where they had about 30,000-40,000 offices throughout the country, but they also went into significant to their online banking systems, the mobile banking, and all other ways you can compute banking in real time, anytime, from anywhere in the world. The systems were struggling, right? Their traditional legacy systems could not handle that additional traffic, those additional transactions that were coming up every year, 20-30% growth in terms of transactions. And they obviously wanted to comply with different regulations that were happening in Russia as well as globally that they had to comply with on doing KYC checks, on doing customer validation, on doing 2 or 3 way authentication, token authentication of their transactions, securing the transactions and encrypting it to certain international standards. All of that required significant manipulation and slowing down of the transactions, and it was really a problem. They had 130 million customers, and that were in real time transacting, and it's just a messy situation. So they were thinking about what to do, how they can in real time improve their fraud prevention techniques, improving their compliance with different regulations and different global policies, while still processing those transactions in real time very fast to the level of satisfaction to their users. And they've looked at about 10 different companies that basically provide some kind of in-memory computing platforms, because they figured that they wanted to be scalable, they wanted to transact in real time, and they couldn't do that with the way that they were doing things now. They had to be fault tolerant, they had to be scalable, they had to have that transactional consistency. That's very important, right? Because in financial transactions, it's not just transactional consistency. I would say it's financial or banking transactional consistency, that if there's a problem or there's a failure in the transaction, you want to roll it back to the safe point sometime in the past. So that type of consistency, that type of satisfaction with different requirements, they could not find with any of the competitors of GridGain, even though they've evaluated some of the even bigger players. They've looked at Oracle, they've looked at SAP, they've looked at some of the IBM and some of the other larger players, but with the way that they wanted to operate, scalability, ease of deployment, hardware independence of the cluster components, all this fault tolerance that they needed, they just could not find a better fit, and they chose GridGain, and they are quite happy. And the test that they've done, which really stunned me there, they ran about 1 billion transactions per second, and on those transactions they were actually implementing those anti-fraud models and the checks that they had to do, based on some of the slides that I showed you earlier, some of those more advanced techniques that they wanted to use, and they still had that huge transactional processing power with their systems. And what's even more interesting, that test that they ran with that 1 billion transactions per second, they did this on 10 Dell R610 blades. They're high-end blades, but they are still quite cheap. They're about $2,500 per blade. So they put those 10 blades together for about $25,000. That gave them about 1 terabytes of memory, and 1 billion transactions per second were processed. So it's just an example of how you can take a bank that is processing so many transactions, so many different ways, struggling with applying analytics on those transactions because they're just afraid that their current performance and processing power is not going to be good enough, and then changing the architecture in such a way that now it's not an issue. And if they need to go to more transactions or more memory, they'll just add a couple of blades. They don't have to be the same Dell blades. They can be anybody's blades, and they just add them up to the cluster, and so they will get that scalability that they need while still operating with that super fast performance. Something that's definitely required for fraud prevention techniques. This is an interesting slide where the CEO of Sberbank, Herman Gref, he spoke recently to RBC, Russian Business Consulting, that basically quoted him that he said, well, the Sberbank needed to introduce new products and ours needed to be compliant, needed to be reliable, and needed to guarantee satisfaction to customers with the transactions that they do. And then they looked at different vendors, and then they chose GridGain, which they believe is going to give them better performance than any of the other companies that they've looked at. So this, to me, coming from this message coming from the highest person within the bank is definitely a sign of approval and confidence here. And then just don't forget that Herman Gref is one of the sort of most enthusiastic adapters of technology, and and this government and other institutions in Russia or in Europe in general, they respect him. They look at him, as saying, okay, if him with that huge bank, with a bank with 130 million customers, with a bank with 900 million accounts, with a bank with I don't know, I believe it's 80 or 90,000 ATM machines. If the bank of that scale is validating and fully rebuilding their infrastructure, their banking infrastructure on GridGain, that's a significant sign of comfort and again confirmation of what the bank can do with this technology. There are a couple of other examples just wanted to also show you, that also, it doesn't have to be necessarily banks, because, obviously fraud and, issues that we deal with here, yes, they are banking related, but not necessarily. Anybody is, can handle those in any of the other industries. This is an example of Silver Spring Networks, one of our clients that works with smart metering and utilities, and they deliver an Internet of Things platform that basically goes in and collects information from different devices, more than 50 million smart meters, and then information is being processed for billing, for informational purposes, and so on. And so again, obviously they need to validate, any information that's coming in from IoT device, whether that's a valid device, whether that's the valid information that's being sent out, because it's going to be used for billings. So again, there are certain rules and models that they put together that require them to validate this information back to, okay, where it's coming from which exact location, what was the number from the last time, is it a valid increase or decrease, so they do a lot of that validation, that that validation from their perspective, what is fraud and how to combat fraud. And then again, they need to do this quickly, and they do this again within our Ignite processing platform, based warehousing platform that's GridGain driven, and all this information is being distributed onto the cluster, and in real time, all this information is collected. Again, as a part of GridGain, and the database is being used to then later on to actually persist on this data and create the statements to send out to customers. Another example is retail, from the retail space, again with PCI and a lot of fraud that we know is dealing with in online retail space. So obviously Newegg is a good example of a company that's struggling with some of those fraud detection methods, and a way of, again, stopping them while they're happening, stopping those fraudulent transactions before they allow it to penetrate deeper into their infrastructure. So this Newegg is the 11th largest retailer in the US. It's an online consumer electronics store, and they've also replaced basically their traditional environments with in-memory computing environment, and they had seen significant improvements in performance. But what's more important, they're also able to add different security models. You see this firewall there, right? So within the GridGain security, they also added their own validation and protection methods that they've integrated with our product. And so it's as soon as the order is coming through, it's not even going to go into the in-memory system. It will be stopped and will be checked as a part of that security gateway. And then the additional checks will be performed while the data is being processed within memory. Right, so this is another example of how a company from a non-banking sector, but that deals with transactions and needs that transactional consistency and fraud prevention methods, PCI type of compliance, built in with their systems. So this slide just shows again that we've seen significant data growth, and that data growth is only growing more and more and more. It's not going to slow down. Most of the solutions that deal with fraud and stopping fraud, that they basically rely on this data growth, because they need all this analysis of electronic data to reconstruct, to detect, and to support a claim of financial fraud. And they need to, all this data need to be available in real time to those applications, and that's what this is supposed to do. You need a way of organizing all this data. You need a way of processing this data in a fast way in order to utilize some of those techniques that we talked about today. The other part of this puzzle is that, well, the cost, as I mentioned earlier, of memory is significantly dropping. It drops about 30% every 12 months. That's a significant drop. So if you look at the price, the cost of this today, it's just maybe slightly over flash, and getting closer and closer to the cost of the disk. And so that's basically where we are today. Everything is dropping, so it's much cheaper to build a system that can perform hundreds of times better today using in-memory. And so if you are thinking about introducing a new technology for real-time analytics, for real-time modeling, for real-time pre-processing of data, for real-time matching algorithms and so on, I don't think there is a better technology today than some kind of in-memory solution. Gartner names GridGain a cool vendor for in-memory computing. We got a lot of awards from most of the different analysts, Gartners and others, and I think there's a reason for that. Now let's talk a little bit about what GridGain is. GridGain and Enterprise Edition is mainly, is what most of our bank customers are using today. It's fully based on Apache Ignite, so we are open source based, where we take the advantages of open source, such as global contributions to this, independence from the country perspective, constantly growing community, cheaper prices, and so on of open source, but also providing some of the enterprise class features that our large customers and small customers, especially in the banking world, will require. They will need certain security features. They will need certain support features and so on. I'll talk about them in a second. But before I do that, let me explain maybe a little bit about the architecture of GridGain and its in-memory data fabric. So basically, we have multiple grids that are connected together, all within a scalable clustered technology using memory. That's what we basically, so, and as I said earlier, we have them all interconnected to each other. So if you need to compute on the data, you can do this right on the same machine, you can do this right on the same cluster, you can do this right on, as close as possible to the data on which you'll do that computation. And we believe that's really an advantage and a performance spark for us. But also streaming is supported, Hadoop acceleration, which is extremely important for big data utilization applications, such as the ones that we've talked about in fraud prevention methods. Clustering, events and data structures, as well as messaging. Now, this is a little bit more information here that will show you different features that we introduce and which grid and which component within this data fabric is responsible for those features. So, for example, we fully support SQL. Not too many of our competitors do that, right? So we support standard NCSQL on any of the data elements that resides within the data grid. We perform high performance computing and risk analysis, and some of those elements that I've mentioned are extremely important when we need to compute for fraud, when we need to do the validation, when we need to do different business models and analyzing behaviors of the transactions. That's extremely important concept here. We also go with scalability and high availability, again, because of banking requirements. Obviously, everybody's concerned. Well, what if my power goes down? What if one of the computers in the cluster goes down? What if something happens with the memory? Memory gets corrupted within one of the boxes. Well, we have thought of this, and there are very advanced high availability mechanisms pre-built within the data fabric to prevent that. We also do real-time analysis and big data and monitoring within streaming. That's, again, going to be extremely useful for fraud analysis and prevention. As well as the next one where we have big data and batch processing, also for Hadoop specifically. If big data is being utilized, then Hadoop acceleration is a must to attain the levels of performance that we need to process real-time financial transactions. Clustering, again, with fault tolerance, with auto rebalancing, we pay a lot of attention to making sure that we are as reliable as possible and as available as possible, regardless of the events that may happen. um, some additional algorithms and data structures like complex event processing and event-driven design and distributed queues and atomic variables and many other data structures will also be supported and available throughout any of the compute patterns on the data within this data fabric. I think we need to talk a little bit about flexibility and enterprise breadth of in-memory data fabric. So we are completely agnostic to your development environment, whether you use Java, .NET, C++, SQL. We will support in any way possible. We have adapters for that. Internet of Things I mentioned, the enterprise applications, social media, right? Sometimes we need to check for doing background checks and other analysis against to combat fraud using different social links. Again, those are provided with our system. There are links to some of them. There's again some of the structured data using SQL will be supported. Unstructured data, Hadoop, all of that is supported out of the box. And the main benefits clearly there's high performance with all this load balancing, high throughput, caching, and memory indexing. We pay a lot of attention to performance improvements. Scalability obviously is important component here, and we are agnostic to the hardware that that you will want to use to scale to add additional cluster members. Full high availability, and again, there are documents that would be happy to see how we reach that. But I think again, from the banks, from working with different banks in the ways that they analyze our technology, I can tell you that they're all very excited and very happy with a lot of attention we put together to guarantee that high availability for banks. Transactional consistency and compliance, persistence, security obviously is an important component here as we fully support authentication, authorization, encryption, tracing and auditing that's always required from the banks to make sure every transaction, every element, every model that had been tested again, with that transaction had been recorded somehow without affecting performance of that transaction. And as I promised earlier, I just wanted to mention some of the GridGain features, enterprise features that will be in addition to Apache Ignite, the open source that is provided with the platform. Obviously, there's a management and monitoring GUI. There is this enterprise-grade security that can be also enhanced with your own custom models, as in the case of one of the customers that I'd shown you with with a case study here. Also network segmentation, recovery local store, rolling production, data center replication, enterprise level of support 24/7. We can provide that support for your transactions. Obviously, financial transactions need that type of support because you're dealing with different mediums of sending those transactions. And as I mentioned with the case of Sberbank, those transactions are coming in at any point and you need that same level of scrutiny and modeling and analytics to run through those transactions regardless of where they're coming from. And then obviously all the releases and patches will be available. Here I just have again more of analyst validation, which again shows that we've mastered this in-memory data grid space, and especially good for financial institutions and for those that need to analyze transactions and do put much of OLAP into OLTP. That's what I call it, right? So you have the analytics, but you need to perform it on the transactions, on heavy transactional system. That's where I believe our strength is the clearest. Thank you so much. That's been my presentation. I'll be happy to answer any questions that you might have for the next 10 minutes.
Hi, Eric. Audience, go ahead, and if you have any questions for Eric, please go ahead and enter it into the panel in the GoToWebinar control panel. So far, there are no questions. I wanted to invite the audience to our next webinar on November 2nd. Eric will be presenting Powering Financial Spread Betting with In-Memory Computing. And if you can't make the date live, go ahead and register, and I'll be sure to send you the recording as well as the slides afterwards. And we'll be continuing this financial services series throughout the rest of this year and into next year as well, with different topics. Okay, I don't think there are any questions. Eric, thank you so much for the presentation today. And audience, thank you so much for attending, and we hope to see you in the next show and in the future as well. Thanks again, Eric.
Thank you.